Now that we know how to find asymptotes, holes, and intercepts, we're going to look at how to graph a rational function. If you don't know how to already find those things, I would look at my last few videos to figure out how, but I will do a quick review of those. So this is the function that we've been working with that we're going to try to graph, but let's look back. To find vertical asymptotes and holes, that's where the graph is undefined. So you want to factor the denominator, set the factors equal to 0. These points give us undefined points where the graph doesn't exist. And those points look like holes if the factor cancels, and the undefined points are vertical asymptotes if the factors don't cancel. So looking at this example, we factored the denominator. The x minus 3 canceled, so 3 is a hole. To find the y value of the hole, we plugged 3 into the reduced equation and got 1/5. And then x plus 2 was what was left, so x equals -2 gives us a vertical asymptote. If n is the highest exponent of the numerator and d is the highest exponent of the denominator, if n is less than d, the horizontal asymptote's at 0. If n is greater than d, there's no horizontal asymptote, and if they equal, you divide the coefficients. So looking at this example, n, the highest exponent of x in the numerator, is 1, and d is 2. Or you could look at the reduced equation. You have x to the 0. 0 would be n, and 1, x to the 1, is the degree of the denominator. So either way, n is less than d, which means that y equals 0. And then we looked at x and y intercepts. For an x-intercept, you plug in 0 for y, and a y-intercept, you plug in 0 for x. For each part of those, you have to make sure you keep going back to the reduced equation. You're going to get a wrong answer if you don't. The only thing that you're allowed to go back here is horizontal asymptotes. Everything else, you have to look at your reduced equation after you've canceled anything that cancels. So now we're going to look at how to plot this on a graph. Asymptotes are plotted as dotted lines. A hole is plotted as an open circle, and the y-intercept is at 0, 1/2. So we can connect these two together and assume it's going to keep going closer to the vertical asymptote and keep going closer to the horizontal asymptote. But we don't know what's going on the left side of the vertical asymptote. Whenever we don't know what's going on, we can just plot points. If we look at -1, -2, -3, or -4, or anything below those numbers, we can plug that in for x in the reduced equation, and we can get y. So that's 1 over -3 plus 2. That's 1 over -1, which is -1, which means when x is -3, y is -1, and that's a point. So that means we're going to be down here on this part of the graph. And we'll look at a few more examples of graphing in the next video, because graphing can be kind of tricky, especially when you have 2 vertical asymptotes and 3 sections that you have to look for.